So next up is Peter. He co-founded a company called Neo Technologies that created a database called Neo4j that you might know. But now he has co-founded a new company called Mapillary, and he will talk about how they use Docker in the backend.
Hello. Does it work?
Yeah.
Cool. Yeah. So I just wanted to tell you a few things I've discovered over the last 3 weeks trying to build a Mapillary in a box. Mapillary itself is quite like a data-intensive system where like letting people upload images, and we build 3D models from it, and we process them for like image recognition and so on. Looks a bit like this. I will try to reload these on imagery slides. I have to reload it. But you basically upload images. You know probably this from Game of Thrones. But what we do from these images that are just taken like 2D with GPS, we build kind of the depth map of these, so you can go. These are the image planes that you see there, random images from people, and then we kind of let me see if I can reload it once more, just so you get the gist of it. Here, you can see that we actually built like a depth model of that whole space, and that's globally happening incrementally over time with randomly generated images. So you can then do that. And yeah, there's a lot of deep learning involved that we're doing, classifying images, detecting skies and roads and lamp posts and whatnot, and street signs and so. However, in production, we are running right now our databases on Amazon on provision like virtual servers, and everything else that's not persistent is running on Docker and especially on Mesos with Chronos as the scheduling application. Looks a bit like this. I can show you this actually. Looks a bit like this. We have a number of different machines here that are running different instances and different CPUs, and so that allows us to pack the underlying Amazon hardware much denser, because we can then see how much space do we have in CPU and so on. For monitoring, we're piping this into UDP, into Rima, which is a closure little in-memory streaming server, and you see this is like going by web sockets directly to the server, so we get a live dashboard, and that's where our thresholding is happening. So if anything is out of the ordinary, sliding windows and so on, we post messages into Slack, and also we pipe this into InfluxDB that then does the nice charting over time and so on, so you can see how things look. It's a time series database, so we get all this nicely ordered. We only have 1.5 people on the back end, so we need to be efficient here. It's a startup, right? So yes. Why would I do a local setup? This works awesome. It's super nice. However, 3 weeks ago we needed to change, to prepare the change of Elasticsearch from 1.75, which is the last of the 1. Series, to 2.3, and 2.3 has API changes. That means basically we need anything that touches that thing, which is all of these images, needs to be upgraded at once, and we need to stage that in some way, and no one really dares to do that because things will break and the whole thing will just kind of blow up. Even if it is super easy to do, it's just you need to prepare all the code. So why would you need this local setup of everything when you have all these nice staging environments? One system documentation, we thought about a architecture overview, but really that's not that useful for someone who comes in and wants to do things, and it doesn't give you confidence of actually running things on your machine and deploying things. Also, for things like database upgrades or changing the message formats, we're using an event source system. So Kafka, the event source, is in the middle, and if the JSON format of the messages that flow through there, around 500 a second right now, is changing, then a lot of downstream stuff might break. or at least you need to test it, right, locally. And also, we thought about the staging environment, but that introduces dirtiness. Like someone needs staging for processing new images, someone needs staging for testing user signups. And then you try to keep that up to date, and you end up with like very, very dirty half hacks that are in there. So why not just grab that? We didn't have a staging environment before, we deployed everything to production, since event sourcing lets you rerun things and so it's very forgiving in that respect. But still, that doesn't hold anymore. I don't know, it was just my computer. So by building the box, we thought, well, okay, let's bite the bullet. Before I do anything else, it took these 3 weeks to do it. So the first thing that we found is that Docker works really, really well. So let's Dockerize everything. We use Docker Compose for our little box. So we get it actually quite clean. You see here our little Mapillary base Docker Compose. It's not that easy to say, but to see. But basically, for instance, for Zookeeper, we use like this special, use as many standard images as you can. For the databases, for instance, just pull these Docker containers off the web and stage them locally, so you don't have to fiddle around. So there's a lot of like standard database setup. There's Storm, and there's Elasticsearch, there's Postgres, there's Kafka, there's Rabbit, there's Redis. There's actually here. That's another thing. Try to fake anything external, so you don't have to have Amazon dependencies and so we pulled in a little fake S3 server that actually emulates Amazon, so we can deploy with the Amazon tools to our little local server that does this. Fake S3 is named. It's really, really useful. And then comes our actual, local code, and here we just pull in containers. What the thing here is, make also sure you have a central configuration. We started out with just configuring things in local environment variables and so, but try to do like console or whatever. We have a home hacked little Redis server system that just does like Python scripts against the Redis server. So you just insert it into a database and you namespace it a bit. And the nice thing about this is it's really easy to then get out again. So if you use this, for instance, you can just say, our cluster config list default, that's the default namespace, it just lists to that thing, or it does, export default, that's our default namespace for the, it actually will source default. It will then export this in an export format, you pipe that into a file, you source that file, and you have all your environment variables that you need. So it's like really low tech when it comes to configuration. And then make sure that the containers are not leaking. Normally your code leaks all kinds of stuff. So when I started this, first thing was I actually inserted users into the central database, which is not the best of things, because, so I had to hunt for a week through all the code to just pull out all the configurations. We had the central configuration, but no one really cares to really do it. So once you switch off network and start to deploy your Docker containers, you will see what happens. And there's a lot of stuff breaking suddenly. So also, what we do here is a little trick in Docker Compose 2. We actually set up a root of our services that we use ourselves. So you see, like environment, this is the only thing we insert, and insert that as late as possible. These are the Redis endpoints for our cluster config, which were hard-coded into the Docker containers before we did this. So if you deploy the Docker container locally, you would actually join the production cluster, right? Because it would pull out the configuration and it would join all the endpoints, if you don't do VPN and so, but still, it's leaking like hell. So we pulled all that out. So now it's inserted here, and there's no configuration. No Docker image should ever start without outside configuration. That's like, it's super dangerous. And it works apparently, but suddenly it leaks, right? So, and then we mount a number of images, of mount points that all these services have. especially this one, a cluster disk. That's one of the reasons we don't do databases in Mesos yet, because there's no good way to mount like shared volumes and so for state and finding that state again with your different cluster nodes and so. But still, that lets you, for instance, our fake S3 has then the local, here's images that are in our buckets. These then hold state over even you killing the Docker containers. So if you did setup and so, you can fast go back to a common state without needing all the initialization of your databases. So hopefully you can store everything on a central space, and then your Docker containers, even their databases, are kind of ephemeral, right? Another interesting thing is think about staging. Docker Compose is really easy to set up, but there's no concept of staging or running cron jobs. If you have one-off jobs that need to like harvest things or batch process things or so, there's no real support for that. So what we do is just to have a keep alive script that keeps the Docker container online, and then just run things on these things. So what we want to do is actually make the system more resilient, a bit like OSGI or something. So the services ping their dependent services and detect when they're online, when they're in a state that they need, kind of like endpoint URLs. What has been proven really nice is mount the org sources. So if you're running like Ruby or Java or whatever, make not only the container, but mount the original. So the container will be mounted. You will probably do a git checkout in your container definition, and then you will go into there and run your stuff. However, you can also mount out of your Docker container, something into a common place, so you can go and actually fiddle around with the org source that you might have, here on your computer in IntelliJ. So you can run the whole system locally, and everything's configured. What I showed you with the list configuration, that was actually like inside one of the worker nodes, and you can just go on and send messages through the system or do stuff on your one container sets to another, and just modify it on the fly outside. And when you're satisfied, then you can commit that into the repo, build a new Docker container, and actually test with that. So you have like 2 stages. So you don't have these micro build your Docker containers all the time to deploy them, because that's kind of time consuming if you have like 20 of them. So you want to have a faster turnaround. So everybody can like screw around with their little part of the system, and then see. And actually, we thought we had a good system, but we found loads of places where things are just like leaking. So it feels so much more confident. This is not a production setup, but it makes you much more confident that you can actually change things in the system that go over, unit test and integration set test borders. Like, as I said before, upgraded databases, or just like putting in a new system somewhere and see what happens, or just bootstrapping the system. Like, can you bootstrap your system? We now have discovered a catch-22. Like, we need a privileged app to do the first auth and sign up a user, but we don't have that app yet. But the app has to be created by a user. So someone like hard-coded this thing in, and the system is right now not bootstrappable. So these are things that make you more confident that they document how things are done without you writing down anything. Yeah, just a very short thing. Okay, cool.